Comparison test. There's direct comparison, limit comparison. All right, there's a lot of words right here. If one's bigger and one's smaller, so B is the bigger one, A is the smaller one. You might get confused. We're trying to do this faster, right? You can remember it with the pizza reference. You can read it yourselves. I don't care. It can jumble up in your brain. Same thing with the limit test. This is about one being bigger or smaller, and say, hey, if you can divide them on top of each other and the limits come out to a number, they either both converge or both diverge. Great. Um, Maybe hard to remember. So I'm going to call this something different, the close enough test. You just get rid of everything else that's garbage and take it down to look to something that's close enough that you already recognize. Here's the for example. I'm going to take this first one right here. Let's get rid of this -5 because the 3 to the n is the one that matters on this term. So just get rid of the garbage that doesn't matter as you go to infinity. So I'm really just left with 1 over 3 to the n. That's the same thing as 1 over n to 3 to the n, which is 1/3 to the n power. That's ratio test. Geometric series. I'm not ratio, geometric series. The ratio is 1/3, so we know this converges. Let's take this one right here. Okay, let's expand this out. That's n plus 1 on the top. This is going to be n squared plus 2 to the n on the bottom. Let's get rid of things that don't matter. This 1 doesn't matter. N squared is way more powerful than 2 to the n. That doesn't matter. So I have n over n squared. I'm going to cancel out one of those n's. So I'm going to say this is close enough to 1 over n. And 1 over n diverges by p-series test because the p is 1. So this original one will diverge. We'll just believe it does. This one right here, let's get rid of things that don't matter, like this plus 2 to the n. What am I left here? The square root of n cubed, which is the same thing as n to the 3/2 power. By p-series test, that p is greater than 1, so this converges. Therefore, the original converges. Next one right here, again, get rid of what's garbage. This 3 to the n cubed matters way more. So I have an n on top, and I have n to the 3/2 power on bottom. I can cancel out one of those n's with one of the n's right here. So I'm left with 1 over n to the 1/2 power. That's a p series, but this p is less than 1, so we're going to diverge in this case, and the original would diverge. Next one right here, I don't care about the -1. I only care about the rest, so that's like 1 over n to the 1/3 power. That p is another p series. That p is less than 1. We're going to diverge. This one right here. Again, this doesn't matter. You know what else doesn't matter? Coefficients. Just getting rid of them. It's the same. This is close enough to 1 over n. And 1 over n diverges by p series because the p is 1. So the original also diverges. Let's check a few more out. This one right here. A, I don't want this -3. I don't care about this. So I'm left with 1 over 4 to the n. But treat that as 1 over the n to the 4 to the n, which is 1/4 to the n power. We're on a geometric series. Our ratio is 1/4, so we're going to converge. This one right here, let's get rid of the garbage we don't care about. This stuff on the bottom, these terms just don't matter. Coefficients, they're gross. So I'm left with n over n squared. Guess what? I'm going to cancel out one of these n's. I'm left, basically, this is close enough to 1 over n, and this is going to diverge by p series because our p is 1. This one, treat that as a 1. Hey, same thing. This diverges again by p series. This one right here, let's get rid of stuff that doesn't matter. That doesn't matter. That doesn't matter. This doesn't matter. All right. So we got 2 extra n's down here, and I'm going to take this. We're left with 3 down here. So it's really close enough to 1 over n cubed. We're close enough. This one is a p series. P is greater than 1, 3. So this is going to converge. That means the original converges. Next one right here. This doesn't matter. Cancel out one of the n's. So I'm left with close enough to 1 over n right here. And this is going to diverge just like the 2 above us that we did. All right, next one. This doesn't matter. So I have 1 over 5 to the n. Hey, similar pattern here. So that's 1/5 to the n power. By the geometric series test, my ratio is 1/5. We're going to converge between -1 and 1. This one right here, the +2 doesn't matter here. All right, now I have a square root of a squared. Guess what? Oh, 2 doesn't matter. Let's just take that down to 1. I don't want coefficients. So I'm left with the square root of n squared. Those two things are going to cancel each other out. So I'm left with 1 over n, and like boom, 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 everything else. This is going to diverge by p series by close enough comparison test. Limit comparison. Sure, let's call it that. I don't care. This one down here, +4, goes away. 1 over n squared. That p is bigger than 1, so we're going to converge by p series. This one, that goes away. I've been doing a million of these, so it's 1 over n. Oh, it's close enough to 1 to p series. P is 1. We are going to diverge. That's it. Close enough test. Go for that.